Welcome everyone to today's webinar. My name is Alexander Lucas. I'm a senior researcher at InSTORE in the Center for Power and Energy Systems, and I'm also the technical coordinator of the InterSTORE project. It's my pleasure to host as a moderator this webinar. We have a very distinct set of speakers to address today's topic, which is interoperable concept for energy communities, and we will present different perspectives from the InterSTORE, the FLEXCHESS, and PARMENIDES projects. These projects come together because they are part of the same call, the European Horizon Europe European call that came out in 2022. Which aim to tackle interoperable solutions for flexibility services using distributed energy storage. And at the time, the Commission set as main expected outcomes three major topics. So the first one, on one hand, there was a new generation of energy management systems that should be implemented to provide the capability of hybrid energy storage systems to work as a conventional single battery energy storage systems, but with enhanced performance. So here performance could be regarded in a very wide concept. This could be improvement in lifetime, improvement in efficiency, in cost. So these different angles are being covered by the different projects. And also a hybrid energy storage system can be also a combination of different types of technology. So even electric batteries from electric vehicles, electric vehicle batteries, the home batteries, heat pumps, so a combination of different technologies. And also another topic that was launched as a challenge was agreeing in a wide scope of stakeholders, including EV communities and other sources of storage, on a common protocol that could connect different storage applications. And a third point would be an SSH approach, which has gaining a growing importance in many of these European calls. And so here also included this aspect of the validation of user acceptance and demonstrating concepts that ensure privacy, liability, security, and trust in connected data spaces, which is one of the topics that we addressed in the InterSTORE project, for example. And today we brought together representatives of the different projects. We have the pleasure to host the first presentation by the PARMENIDES project. So we will have Mark, Stefan, and Vieri Emiliani. Mark has been is an expert in computer science with a distinguished career in academia and industry. He earned his degree in computer science in the Vienna University and Technology, and also his PhD. He has experience in the Robert Bosch, very well-known company, and since 2014, he has been quite a crucial part of the Center for Energy in the Austrian Institute of Technology. We will also have a speaker for the PARMENIDES project, Vieri Emiliani, is head of innovation of MAPS Group, which is an innovative SME. And he brings more than 25 years of experience in R&D, engineering, and business development in the information technology industry. And so FLEXCHESS will bring this perspective, PARMENIDES will bring this perspective From the point of view then of the energy management services, well, they intend to develop these new energy management services for hybrid systems and to enable interoperability and exchange of data. And the project aims to develop new ontology with a focus on electricity and heating domains for buildings, customers, and energy communities. After this, we will have the presentation by the FLEXCHESS project. Here we have the pleasure to have Habib Nasser. So Dr. Habib Nasser holds a PhD in mechatronics and smart systems. His research was focused on autonomous and smart solutions, and he has experience also in both academia and industry. And he's currently the CEO and co-founder of the RDUP, specialized in development of digital technologies. The FLEXCHESS is, as a project, they're developing multi-levels flexibility approach based on virtual energy storage systems. And the idea here is to store surplus energy through hybrid energy storage systems, modify the behavior and architecture to support and predictable growth and change in demand, let's say. And then we will have from the InterSTORE project, Nikolai Candelari. Nikolai is a project manager. He's data scientist at Cybergrid. He holds a master's degree, and so he's been focusing very much in a lot of the developments in InterSTORE, but he in the project provides the view of an aggregator, and they are incorporating many of the new features of the InterSTORE project in their own platform, which is the CyberNOC, and so he will present his point of view in the topic that he's putting forward, which is the integration of energy communities via the new protocol IEEE 2030.5. As for the InterSTORE project itself, we had many developments foreseen in the beginning of the project, and so far so good. So we are putting forward a new version of the IEEE 2030.5 as an interoperable toolkit. On one side, it has the native client server library for native installations on the side of on the equipments themselves. And a second development is a legacy protocol converter for existing equipment that may communicate right now with different protocols such as Modbus or MQTT. And so this enables the conversion to the IEEE 2030.5 standard. Another development in the InterSTORE project is we have 4 new energy management systems being updated with new features to incorporate the integration of distributed energy resources, specifically hybrid storage systems. And we also have, as a 4th development, on the data space area, where we are leveraging the developments of the OneNet project, so the OneNet connector. And so many of very, very, very important features were ensured, were developed here in InterSTORE. And so we have a new version of the OneNet connector. Now we call it InterSTORE connector, being made open source. And so I would invite everyone to look at these solutions that are open source and available on GitHub. And so last but not least, I have the privilege to also to present the moderator for the panel discussion, the very esteemed Ludwig Card from the Baum Group, and we have the privilege to have him from the INTNET project, and so he will be moderating the discussion. And without further ado, I would pass the floor to Mark. Mark, whenever you want, please.
Yes, good morning. Thank you very much for the nice introduction. I will now start together with Vieri to give you an overview about the PARMENIDES project and how we want to develop interoperable concepts for energy communities. And since I'm the first one, I will start with a short introduction about general aspects. In the generation side, we see a nice growth in the share of renewable energy generation in the final energy consumption. In 2022, we had around 23% of renewables, and this is slightly above the trajectory, which is around 22.2%. On our goals of 32 for 2030. And as you can see in the electricity sector in Europe, we reached already 41.2%. Not that much in heating, cooling, and also transportation, but we are growing, and this side of the generation will be a very important aspect for our project, of course. And on the other hand, on the consumption side, we know that around 40% of the energy which is consumed in the European Union is used in buildings. And especially when we have a closer look to the electricity consumption, we see that the residential consumption is around 27%. So we have a lot of renewable generation, local generation. We also have a big part of the consumption on local actors. And this means that there might be a big potential for energy communities to be an active part in the energy transition. And here you can see some of the main ideas what energy communities can do in future. And it's more or less to support that investments are taken. They should create an internal and a cross-border market. They should support the security of supply, and they should also improve the environmental situation. So there are a lot of aspects which can be taken by energy communities. And now I want to show you how we tackle some of these challenges in the PARMENIDES project. PARMENIDES stands for Plug and Play Energy Management for Hybrid Energy Storage. As already mentioned in the introduction by Alexandre, we tackled hybrid energy storage systems as one of the core aspects, and we also want to develop new energy management systems. As one interoperable concept, we decided to develop an ontology which we called PARMENIDES Energy Community Ontology, in short PECO, and an energy management system which is capable of using this PECO as knowledge base and to control these hybrid energy storage systems. And therefore we called it EMS for HAS. So we want to activate this flexibility of the hybrid storage system, which we see as a virtual abstraction of different storage technologies which are available in the field. And in our consortium, which is EIT and Energienetze as a DSO from Austria, we have MAPS and R2M solutions from Italy, Trialog from France, Delab from Germany, KTH in Sweden, and Experiencia from Switzerland. We decided to implement or to have a closer look into 8 high-level use cases, which are, I would say, standard use cases like baseline accounting and ex-post energy allocation, more on the virtual level, because this is just a baseline for assessment of our solutions. And then we will have participant optimization, participant incentivation, and participant disregard as use cases implemented in the Swedish demo at KTH, where we have the students in the apartments as integrated in the use cases. And in Austria, we will tackle grid friendliness and grid support by energy communities in 2 smaller municipalities in Styria. And how this could look like. Okay, I think you cannot see the animation. It's already full. The final picture is already there. Vieri, can you confirm that?
Yeah.
Okay. Then I will, since there is the animation is not working, I can give you an overview how this picture can be interpreted. On the left side, you can see different devices which are installed in the field. We have grid monitoring devices providing measurements from the low voltage grid. We have smart meters at the customers. we have electric vehicles and charging stations, we have home energy management system, and the battery storage system. This can be extended to whatever storage technology we want to have. And via a gateway, all these measurements are published on a MQTT broker. And these measurements are considered by a grid capacity management. This grid capacity management is a software solution running in a very high resolution, relatively high in 1 minute resolution. And the idea is, based on the measurements, based on the trained model in the background, we want to calculate how the controllable devices like charging station and battery energy storage system can be operated. So we will calculate the maximum and minimum power for all controllable devices. These limits are again published and used by the energy management system. The energy management system will run in 15 minutes resolution. It calculates based on these limits, based on the measurement, it calculates the set points for each controllable device. And to ensure that these set points in 15 minutes resolution are still within the limits from the grid capacity management checks again the set points, might clip it if they are above or below the range, and then they are further communicated to the EV charging station and the battery energy storage system. So we run an optimization at the energy management system, which can be cost optimization, environmental optimization, or somehow related to comfort at the customer, while ensuring that we do not have any grid violations. The left side you can see here. So the energy community itself will be modeled by the energy community ontology, which I mentioned in the beginning. And the pilot-specific instantiation of this ontology is used by the energy management system, so to say, as its main knowledge base. And the big advantage is we can have a separate knowledge base, and we do not have to implement all the things directly in the energy management system. This energy community ontology, we decided to create a new ontology. We discussed there are a lot of ontologies already available, but none of them is covering energy communities or hybrid energy storage systems in particular. So we decided to model the energy community with its members in this by using the ontology. There is the opportunity to define a number of different assets, generation assets, storage assets. We will have some classes for tariff information, for incentives for customers, but also for forecast, user integration, and so on. So I do not want to go in all the details, but I want to highlight this concept of hybrid energy storage system. In literature, there is no clear definition what hybrid energy storage system means. And therefore, we try to define it in a way that it is generic enough to be further used, but also very specific. Before giving you these details, I want to refer to this paper, which is published in Open Source Modeling and Simulation of Energy Systems, OSMSES conference this year in Vienna. So if you want to have a look into further details, please have a look into this paper from our main author, and so from KTH. So we define a hybrid energy storage system as the combination of at least two energy storage mediums with one or more different energy carriers as input and or output. These carriers are coupled through energy coupling devices. We are using lines, buses, loops, networks, whatever is necessary to transport. And it's designed with a specific topology. And the idea is to be able to control this hybrid energy storage system via an energy management system. So in the end, we will build a virtual abstraction of different storage technologies with some specific characteristics about their power and energy inputs and outputs, the capacity, some constraints, the efficiency, but still the physical devices stay as they are. The big advantage is, or the idea is, that a software solution can use the information from this hybrid storage system, infer some additional knowledge about how to convert between the different storage technologies and which one can be used for optimization in the best way. In the end, this definition supports a modular approach, so it's a basic framework of the different systems and properties. It's configurable. It can be extended by further technologies. It can be scaled up in size and complexity. And as one of the main ideas of the project, it should be an interoperable concept and support the interoperability in communication and software implementation independently from which language or standards we use. And with that, I would like to hand over to Vieri from MAPS to start the presentation and go into more details.
Okay, thanks, Mark. So the idea is, okay, how the hybrid energy storage concept framework can be used in the context of energy communities to better exploit the potential of flexibility potential of those aggregates of buildings, residential and commercial buildings. So the whole fact that, as Mark already mentioned, we have 40% of the European energy consumption is on residential sector, but on the and the electricity, the electrical part represent less than a third. On the other hand, in the generation, solar generation, we have more than 80% is on electricity. So there is definitely an opportunity to leverage a combination of those, the coupling of these carriers. And in our example, we see the typical scenario for an energy community. We have the electrical power, but we also have a prosumer, which is more than a rooftop PV and some loads and possibly a battery, right? We've got buildings and they've got the thermal mass, and we've got heating and cooling system that can act as coupling device, like heat pumps and electric boilers, and hot tanks that are, and the inertial mass of the thermal mass of the building that are again possible storage, and that they can be combined and provide additional degree of flexibility to the system. And this can be done at the building level, but it can also aggregate it at the community level, adding further flexibility to the whole community. So the idea that we decide to follow in the PARMENIDES project is to model a hybrid energy storage using ontologies, and namely PICO, as Mark mentioned. So in our oversimplified example, we've got the archetype of an hybrid energy storage with its properties, like the carriers, the storage capacity, the state of charge, charging power. And at the side, we have the two examples of how this can be, how the actual assets can be represented using this framework and archetype, which is necessary to abstract the storage capabilities of different assets. So in the case of a battery, it's quite straightforward to map it to our model of hybrid energy storage. While for the boiler, we may need to resort to physics to represent, given the properties of the asset, how can we say, for instance, what's the storage capacity of a electric boiler or a hot water tank? And using physics, we can actually model the capacity, we can model the state of charge based on the state of the temperature of the boiler, or simply the charging power. In this case, is pretty straightforward, on, off, and the nominal rated power. So the whole idea is that we can model this abstraction and use some languages rules to represent this modeling. We can stick to the, let's say, semantic web technologies and use things like semantic web rule language to implement those rules, those mapping rules, but you can use whatever tool you prefer. But at the end, this allows the EMS to reason upon and manage these assets consistently. So in our example, let's take an household, and I go very quickly through. In a standard scenario,
we should try to wrap up this.
I would do very quickly. So we have in a standard scenario, we just have the battery coupled with PV, and excess power is sold to the grid, and the heater operates in a standard way based on a threshold. While in our EMS scenario, you can have an additional layer of flexibility, coupling the thermal needs with the electrical needs via the coupling device, which is the heater in this case. And we also can handle an optimal planner that combines those two aspects. So to wrap up, we have our goal was to implement a plug-and-play energy management hybrid energy storage system. We started modeling the HESS as a technology agnostic framework for storages, and we used an ontology to represent this, because at the end, ontologies are one of the best tools that we have available for representing knowledge that is needed to reason upon and leverage the opportunities of coupling these different abstractions. This means that we can plug and play assets that are defined according to our HESS model. This could be done in many different ways. We can use, at the end, we just have to think of what are the registers of a Modbus that needs to be mapped and implemented in the connector, and implement all those kind of things. But this is exactly what happens and what is hindering the interoperability in the energy sectors, because at the end, we would like to represent those things using standards. Standards are fundamental for interoperability. We will see in sister projects that will present how these standards can support interoperability, like IEEE 2030.5. But the main point is we need to commit to standard. That's the whole point. It's not relevant which standard we use, but we must commit to standard. This happened in other industries, and it brought a huge advantage that we need to bring to the energy sector. So the idea at the end is that possibly we have to cope with the standards that we have and simply try to adopt them and use them. And that's the end. Thanks.
Very nice. Thank you, Jari. We will have the chance for questions and for discussion after all the presentations. I would give the floor immediately to Habib, please. The floor is yours.
Okay, thank you. Hello, everyone. Thank you, Alexander, coordination team. So I am Habib Nasser from Erdiop, partner in the EU project FLEXCHESS, and it is a pleasure to be here in the cluster and present our project. So briefly, FLEXCHESS aims to develop digital tools in order to aggregate together small...
Habib, sorry to interrupt you. Do you have control over the presentation? Have you switched?
Yes, I can switch.
Slide.
Yes, it's okay.
Actually, I switched it for you, Habib. If you can take control, it will be just easy.
I can switch slides, so it's okay for me.
We cannot see it. We cannot see you changing. I think you have to press the take control on the top of the menu. There's a button there saying take control. That's right. Super.
You can see switching the slides. Okay, thank you.
Perfect. Yeah, perfect.
So as I said briefly, so FLEXCHESS aims to develop digital solution in order to aggregate together small distributed energy storage system combined with flexible loads in order to store energy and discharge or release energy when it is needed by the whole system. So our vision is to use virtual energy storage system and federated real-time digital twin. So that will allow to de-risk and provide flexibility service. And to achieve our goals, we are developing two main layers, as you can see on the right, in the figure. So we have chess node. Firstly, chess approach in our project means not only HSS, but also connected HSS, as the connectivity is very important to provide flexibility. So the main functionality of the chess node is to aggregate together the chesses and allow them to act together and optimize their behavior. For the second layer FLEXCHESS platform, it aims to create a shadow of the chess node, evaluate or assess the capabilities in real time of the chess node, determine which flexibility service can be provided, and which chess owner should be implicated in these services. So as you can see in the table below, so we have 5 pilots in 5 different countries, where we defined 4 use cases that will be tested and evaluated. So firstly, the first use cases is to empower grid stabilities. And here we will test and validate 2 main scenarios, mainly peak shaving and load shifting. For the second use case, to empower grid stability, we will try to provide ancillary services as frequency regulation through the VSS and load balancing. The third use cases, it allows to provide support to the virtual, for example, virtual power plants or energy communities in order to achieve their goals in case of unforeseen conditions. And the last final use cases is for adaptive energy management. And here we have 2 use cases, mainly energy and cost optimization for multi-building and EV community, that it is scenario provided by Slovenian pilot site. So as you can see here, the taxonomy that we provided in FLEXCHESS, and as an overview, so we defined 2 specific workflow for the flexibility provision through interoperability. So the first workflow, to provide flexibility, so for example, the short-term forecasting model will predict all energy resource production, generation, and consumption, interact in parallel with the digital twin in order to assess the flexibility capability of all chassis and chess node, based mainly on state of charge and the chassis capacities that will be offered, so capability that can be offered by the virtual chess node. Then, based on the data received from the physical chassis, the flexibility service provision engine that we developed will generate and send back sendpoints to the different chassis composed in the chess node in order to maximize flexibility and profit. And at the physical world, the smart energy management tool will control each asset in order to provide required services and return back the information to the cloud-based platform. The second workflow aims to optimize the chess node. So based on the received feedback and information from the energy management system, so the digital twin will compare the real world with, and the digital behavior in order to identify, for example, some deviation and possible improvement. The smart DSS that here will try to provide some recommendation and improvement based on the flexibility provided, and will consider many constraints such as technical and sustainability constraints. So for regarding the communication layer, so as you can see here, the different protocols that are used in order to interact between the different layers and different components. For example, between the chassis plugs, and the Flex platform, we mainly use MQTT for data monitoring and broadcasting real-time measurement with subscriber. Between the cloud modules and services, we are using a REST API. And as we have an EV communities in Slovenia, so the standard OCPP 1.6 is used and implemented for remote metering and smart charging. As you can see on the right, so our partner Arcelic is offering and providing gateway to ensure the communication between the two layers, and inverters such as smart plug in order to make, for example, existing assets or existing loads smarter and more connected. And as in the same as the other projects, so in FLEXCHESS, we are also using SGAM layer and methodologies in order to define the use cases in structured way and the scenarios in very comprehensive manner that will allow information and communication layers to ensure that all the parts of the project are well interacted and ensuring interoperability when providing flexibility service. Also, it is used as a guide for during piloting to describe as we are describing the different scenarios and to be tested in the real world setting. And the business layer is used in order to define the different actors that implicated in each flexibility services and determine their roles and the sequences in order to provide flexibility. So in order to we can say ensure trust between the different actors, we are developing smart contracts in order to ensure or to control, to manage the different use cases and scenarios. So firstly, we have one, we can say, cross smart contract that between chess owners and chess node in order to define their contribution and participation rules. And for each use case, we have a specific smart contracts. So for example, for the first use case, the smart contract will be able to consume chess owner chess data, compare and analyze their contributions and their behavior, their profile, and send them recommendation in near real time. So that will improve their consumption behavior during, for example, peak or off-peak periods. For the second use case, the smart contract here will retrieve data from other modules such as energy, EMS, digital twin, store all essential information of the agreement, such as that date of activation, the type of flexibility services, the end of services, and the real amount of flexibility provided to reconcile the concrete transaction. The third smart contract here aims to, for example, for the chess node, to provide that will provide a support to VPP or an EC in case of in specific situation. So the smart contract will be used in order to valorize this support or this amount of flexibility provided and generate as we consider to generate revenue stream. So for the last use cases, so the smart contract will provide rewards to the EV owners who schedule, for example, their charging or to modify their charging profiles according to the grid needs or to shift to the different charging station where the grid flexibility is most needed, particularly near substation in their strain or their overload. As you can see in the last slide, so we have here the user interfaces and the rewarding developed with FLEXCHESS in order to motivate and engage chess owner. This incentive-based platform composed of two systems, mainly the leveling system that will, where the chess owner, for example, will get points based on their contribution. If they, for example, they bring BSS battery or PV or other flexible loads. And we have also a rewarding system that will allow to reward their participation contribution and during the flexibility provision. So as the same thing that the leveling system, so the chess node operator can define or set up the rules for rewarding or leveling. And these rewards can be NFT to be used, for example, in marketplace or win some benefits through the platform, through the ecosystem of Chessnode, or it can be also transformed to coupons that can be used as local market discount to make these rewards use it in the real world. So that's all from my side. Thank you for your listening.
Thank you so much. Very interesting, Habib. Thanks for your presentation. I would pass the floor to the InterSTORE project. Nikolai, the floor is yours.
Yeah, hello.
Elisabetta will have to reshare it.
Yes, I will do it now.
Hello, everybody. Thank you for joining us today on this panel discussion we will have just after my presentation. I would start maybe by who am I? So project manager at Cybergrid. Cybergrid is a company that really focuses on renewables. We are keen on putting every energy we have on the grid from renewables. As you may know, this is quite challenging because renewables, if you have lots of PVs, give you some issues, especially at 12 o'clock where everybody is producing loads of power, but nobody's using that. So in order to really support that in Cybergrid, the company I work at, we really focus on flexibility. Flexibility, the ones you know already are aware of, but the ones who are not, it's an option of energy. So you sell that to TSOs in order for them to be flexible, to manage the grid based on the needs and shortages or surpluses of energy and power. Okay, here's my presentation. Thank you, Elisabetta, for quick work. Let's see, this now works. So yeah, we want to make it renewable. We want to make it flexible because this then stabilizes the grid well and helps us to really go into green future, which we would really like. With that, Cybergrid then has this platform called CyberNOC, which connects on one side utilities, aggregators, system operators, prosumers, or in this case, energy communities, and monetize by offering flexibility to TSOs, usually, their assets. That could be industrial, it could be batteries, and electrical vehicles, or different renewables like PVs and wind. And so the system itself, is software based, which means you put it on your computer, and in the back everything is made automatically from connection to assets to bidding, and everything in between. We really try to make this software really diverse. So this means being able to connect different assets, being able to connect to different protocols, being able to allow different users to come in. And with that, we come to InterSTORE. InterSTORE, we found our pitch here by finding a new protocol, which we are quite keen on, and at the same time, we try to show that this really can work for energy communities. And this is quite a challenge. Energy communities are not the easiest of let's say, assets, just because, you know, these are households. So trying to work with anything that people rely on for daily, you know, lives, it needs to be taken care of really delicately, let's say. Anyhow, so let's start by why the new protocol and why just this one. Maybe we start with how we found it. We found it that, you know, it's widely used in America and Australia and so on. And then we take a closer look on it, and we found that it's a really nice feature, nice protocol focused on distributed energy resources, and that's exactly what we are having here. So we then took it from the basic implementation using REST and upgrade it in the project using nets. And why nets? You know, and what's so important using nets is that nets allows communication to be not just one-to-one, but many-to-many. You know, maybe you don't see the benefits right away, but if I show you the second picture, you know, these are just some of the options you can have using that protocol. So instead of translating one message from the EMS system, let's say in our CyberNOC, to PV in energy community, you can now have 5 PVs listening on one subject, on one message, or you can have a stream service, meaning that you just request one time this data point to be sent, and the device regularly sends it because it's set in this way. And additionally, not just device and AMS system can talk, but devices between themselves can talk, and EMSs between themselves can talk. So this really should benefit the interoperability we look for, and we didn't stop there. We expanded that by what is missing, and what is missing that nobody is speaking this new protocol. So we put in this legacy protocol converter in front, which translates whatever you're speaking until now to the new IEEE 2030.5 over nets. Yeah, so this was developed by kind colleagues in InterSTORE, Sunesis, and they did a great job, and we are trying now to implement this in our places around the pilots area in InterSTORE. And so the pilots we will focus today, I think, no surprise, would be the energy community pilot in Austria, which we monitor, we develop together with partners there. And the energy community we're talking about is the DTAG community in Upper Austria, numbering how many? Let's say 63 participants, and some of them, you know, volunteered to join us. So they offer their households to be used and their assets to be used as a project presentation pilot where we show that this really works, that the IEEE works, and the optimization we want to do with them would really help them and help us. And so let's start with how to connect them. IEEE and on the pages before was shown nicely, but then at the end of the day, you need to connect it directly. And here you see, let's say, I call it full chain of communication. So on the right side, you see the asset or its inverter, which is talking to this box in the middle. We'll come to that through local Wi-Fi. And this box in the middle receives these different data points we request and transforms it. So there's this legacy protocol converter installed and transforms it to IEEE. And based on this transformation, it then sends it through a secured connection, APN is called, to our InterSTORE instance of CyberNOC, which is the EMS, you know, shortly. And this looks fine, but this is hard to do. But let's come to issues a bit later on. I want to explain that if we take the picture from before and expand it a bit, there at the end we added the open data spaces. Why that? Maybe this is a pitch for additional webinar, which will be held, I think, in 2 weeks' time. But this open data spaces really assures that the data we gathered and we would like to share, or we need to share, or whatever, can be shared to different partners, utilities. Let's say in our use case could be DSO, which could be could benefit or be interested in this data to really help the grid stabilize, to be interoperable. Yeah, so in order to have this working, CyberNOC needed to be developed. Okay, the two things which was mentioned a few times now is this new protocol, so interoperability toolkit, we call it, and open data spaces to share the data at the end. However, this is not all. When we got this data in, we need to do something with it, and how to go up around it, and how to really maximize then this value of the data we received is stored in this energy community toolkit. There's also other development, but I will not go there now. So energy community toolkit in general is an algorithm that focuses on maximizing the energy that is produced in the energy community. It comprises, like on the picture you can see it, from many steps. The first one is of course gathering the data, getting it in, and then the CyberNOC was developed to really add the asset automatically, because we foresee this could be used in a wider scale. But more than that, when the asset is added automatically, it really needs to be understood, because we need this understanding of the asset and its behavior to generate its forward procurement, because based on that we then optimize energy we foresee will be produced. How we then work with this forecast is up to debate, but the thing is we divide and somehow distribute the energy between the energy needed for the use of the communities, because this is I think the vital part, which maybe we can discuss later in the panel, that we still need to do this optimization so that the members which are nicely connected to our platform do not feel any interruption for themselves. And so on the other side of these reservations for their own needs, we have bidding of the market as flexibility on different energy markets. So that's how the optimization would benefit the users by putting the excess energy they had on the markets, and the revenues would be split. And last but not least, like I said, I think one time already, it's a real energy community, it's a real household, it's real people, right? So and we're doing something really optimistic, but it's still research based. How do you put that there and expect it to work without any interferences is the key, because you cannot play it with the patience of people, right? And when they try to have a movie at the end of a long day. So to really go around this, we do a lot of testing, and a lot of procedures are set up in the way that they can be troubleshooted when something happens, or we retest the things before we put them on the field. The picture showing here is the 4 guys that are working on the project, who are now testing whatever we would like to put in the community in the lab environment we have. And yeah, so we try to really focus on this stability of this protocol, stability of the optimization tool, and yes, the benefit that could bring to community and to us then at the end, who trying to benefit, so that we aggregators, but more importantly, system in general. Thank you.
Thank you so much, Nikolai. Very interesting presentation as well. So I guess we will open the stage for the questions now. Ludwig, I guess you can take over. Yeah.
Thanks for inviting me, and thanks for being in time. You are 1 minute early. So we have really 50 minutes to go for this little nice panel session. Maybe a sentence on who I am. I mean, I'm working for a company that does a lot in energy research and consultancy, and we are involved in pretty many projects, and also in one of your sister projects called INTNET. The INTNET project deals with, how should I say, fostering interoperability in the energy system in general. And we have been talking with presenters here. We cannot really dig into all the details that you have presented. I think this is not the way we can do that. And as who said it, Nikolai said it, at the end, it's about the real people. So let's discuss a bit about what we really want to achieve a bit on the purpose of the project, on the ecosystems in which they exist, and also expected impact. So we dig into that, but I will follow the chat. So if you have questions on the chat, we will try to involve them in the flow of the panel. When we talk about people and we talk about energy communities, let me give you a quick disclaimer. The Commission has defined in various directives and market designs what an energy community is, and we agreed with the speakers that when we talk about energy community now, it's not necessarily something according to the EC directives, but it is more pars pro toto for all types of collective actions, including local actors. Okay, so don't discuss whether this is correctly formed as a legal person or whatever is in the directive. We are talking about communities that do something together in terms of energy, and we talk about how can our projects deliver to that. When it comes to interoperability, and let's talk a bit interoperability first. I think we all agree that more interoperability will bring benefits to the energy system or the energy system transition, and technically this is probably true. But we also, many people believe that this entire decision is too low in speed for various reasons, maybe political or whatever. But can we with our projects, or can you with your projects, somehow contribute to increasing, say, the speed of the necessary energy transition? Just maybe some ideas. I mean, can you make better markets, make better societal frameworks, better security? What is it? How you want to drive this transition? Maybe from one little insight from every project before we go on. Shall I call you, Habib? You are the first one on my screen, so I call you.
No, it's okay. I think in our FLEXCHESS project, we believe that energy transition has to go in parallel with digitalization. So that's why we can say chestnut are, we provide digital source, more they are smarter, more they are connected. So more will be easy, we can say, to ensure this transition of clean energy, you can say.
So digitalization as such gives more speed. How about the others, Nikolai?
Yeah, I can say that, let's say in InterSTORE, we dealt it directly. Not sure if this is the best approach, but this is how we did it. And that's by introducing bridging of protocols by these legacy protocol converters. Now we focused on IEEE, but I think this bridging of differences, or I think we discussed it before, the open source nature of protocols could be a way to increase interoperability.
Yeah, open source is important. Mark, Vieri?
Yes, I totally agree with what was mentioned. So digital solutions will be necessary. Open source solutions will be preferred. So this was also one topic we had in mind when deciding we want to go for an ontology, which is open source and which can already be used by interested parties. I think we're talking about a very complex system. And if you want to be part of this very complex system, you need to get a good know-how about the system. And therefore, we decided to create this ontology to be able to provide the, I would say, vocabulary and grammar to describe this system. And everyone who is using this ontology has the same vocabulary and can build digital tools upon this knowledge base.
So speaking the same language is a benefit as such.
Yeah,
of course.
I address you, Vieri. You said in your presentation, I don't recall it exactly, but more or less you said it's not relevant which standard you use, but use one. But now we are creating so many ontologies, taxonomies, and everybody invents at the end new ones. Does that help?
Well, okay. As Mark mentioned, currently no ontologies were covering hybrid energy storage systems
that's true.
Or energy communities. And we definitely are in a complex system. But I want to come up with a metaphor from a different industry, okay? In the 60s, in the music industry, synthesizers started spreading in the 60s. And for 20 years, you had each manufacturer with his own protocol standards and control systems and stuff like that, okay? It took it took 20 years. A few people in 81 started developing a protocol which was called MIDI, which is far from being perfect, okay? But, it took 2 years to agree for the whole industry upon this protocol and a few years more to adopt it, okay? Yeah. Now, this protocol, I mean, 1983, its 4th year, it's been updated in 2020, but the new protocol is backward compatible. So it's 40 years that from the beginning, musicians were able to synchronize and control devices and instruments for all different manufacturers, okay? And this unleashed an incredible potential in creativity. I think that that's the whole point. Our peak ontology may not be perfect. We don't need, it can be an inspiration for someone else to elaborate on it, make it better, more compliant with SAREF. SAREF is not perfect. We can, but we must take a road.
What you say, we need to agree. We need to agree on one. Otherwise, we are not going to have the big orchestra.
No, that's, definitely, Vic. The fact is that there's an old joke about standards.
Can I interrupt? Can I ask you something? So I think more or less everybody said something about the smart grid architecture model, so the ESCAM. I know that this was the intention of the ESCAM was to somehow streamline the discussion, to create a taxonomy, or maybe also ontology, I don't know. So why do you follow this ESCAM model? I think I have a hand. I don't know if you want to talk about that, Harvey, but why ESCAM? Why does ESCAM help?
I was just wondering to add another point. I think human in the loop. So I think without the long-term engagement of citizens, or in our case, just owner, this energy transition can't be achieved. So we have to work on informing citizens and increasing the awareness about the energy transition and their benefits. So I think that can be a good point for.
So that is to meet the purpose at the end. So involve the right people, but the right people don't know nothing about ontologies and taxonomies, right? So we will come to that. But let me stress a bit this putting an order in the discussion of the experts. ESCAM, why ESCAM? What? I mean, I don't want you to teach what ESCAM is. I understand that most of the people that we have know what it is, but why did you follow ESCAM? Is it that someone told you don't get the funds if you don't follow ESCAM, or is there a reason? Stefan, you're smiling.
I think it is required in the topic of the call. But in our case, for example, yes, we use a DISGAM in order to have a comprehensive, we can say, description and definition of the use cases and the scenario that will be implemented later in the pilot. So it was even well accepted and by the pilots, even they are not technical partners.
Again, it's not perfect, but it's a reference framework.
Yeah.
I agree, and I think it's always good to have a look on when we talk about interoperability, which interoperability level in the ESCA model are we addressing? For example, if I would go to my parents and say something about interoperability, if they would understand this topic, they would think just about the physical connection. But we have 5 layers, and it's important to define on which level we are working, which level we are discussing, and on which level we are defining our use cases. In the Parmenides case, it's more information, function, and business. Pico is addressing information and above. And in some other cases, it's physical and communication. So you have to ensure that you're talking about the same.
So which one layer? And we will come to layer 6 that we propose in Internet, but later. Which layer would you talk? I mean, when you say you are working with and you're working for energy communities, and we somehow believe that energy communities can foster the transition through the participation, democracy, involving your parents, Stefan. But what is it that you really contribute? I mean, you said your parents care about the physical layer, but they are directly involved in the business layer because they get a tariff. So what is it that you contribute to this energy community discussion so that we get more and more valid energy communities? More physical layer stuff, more business layer stuff? What is it what you contribute from your projects?
I think maybe I can start here, but I think we really go into physical layer and then some business model on it. I think, and I think maybe then colleagues will join me, but you need to go through some layers, not just one, because usually if you just take one, you fell short in something else. And but taking all the layers, it's now hard, right? How to do all of it by just being a researcher, let's say. It's hard, but I think we should try. And in our case, we try to really go, let's say, at least 2 layers, and show why this would work.
And when you talk to your parents, Stefan, so what do you talk? Do you talk about a new type of smart meter, which is not rotating anymore with a red light, but gives you, I don't know, something on an app in your smartphone? Or what is it that people are after?
In the specific case of my parents, of course, they will check their bill. And my father is monitoring how much of his energy production is used as self-consumption. So, of course, this is on a very high level. So we're talking about business levels, maybe functional level, and from what I have seen in the past, the lower we go, the more we are going into technical discussions, which might not be relevant for the public. Also in our energy community, the participants there, they are interested in the result. They do not want to discuss physical connections or data models or something like that. They just want to be part of the energy community, maybe provide flexibility with their storage assets, and in the end would be happy if there is a benefit for them. But they do not care about how an energy management system with GCM capacity topics is working and which data model is used.
And to add
but
to
we
what
have to discuss it, of course. Sorry.
Yeah, and to add to what Mark is saying, I would say that the contribution we try to bring with Parmenides is to provide a way to describe, to semantically characterize and abstract the things that are below the interest of the general public, which is, again, tariffs, bills, self-consumption, contribution to the decarbonization, but they don't want to be bothered with the details. So we had to provide a kind of abstraction and unified framework also on the meaning of the data that we are exchanging. And that's the role we think that can be taken by ontologists.
Maybe I didn't get it, or maybe you didn't concentrate on that, but I have hardly heard something from you guys how you present your ontologies or whatsoever to the final customer or consumer. Are you looking at graphical user interfaces and so, or is that beyond your project?
you don't need to present the ontology to them. You must be confident that the concepts that are described are consistent with what are the goals of the users. Ontologies are good to represent knowledge, but in a machine understandable way. That's why we use them. That targeting the systems, not the humans.
Yeah.
I know.
Maybe I jump in here because I think there's how will they notice? That's the question. And let's say in our case, I rarely think they will notice the new protocol. They will just notice a small box being installed at their house, And that's now the question: how do you present this stuff to them to be low level enough that they understand and they're comfortable with working with that? Because let's say, in our case, we're putting something completely new and completely, a different way they used to. And why should they do it? Explain to them everything, they won't do it. Explain to them too much, too little, they won't do it.
Yeah.
How do you do it? That's now the question.
I mean, we can debate. I mean, I looked at your PICO. So this PARMENIDES energy community ontology. What is it? And it puts the energy community somehow in the center of the interest, but it puts also all the others, the grid operators and whomsoever. And I mean, was it InterSTORE or FLEXCHESS who claimed that it's community-driven profitability? So we are a bit on the layer 5 of the SCOM. It creates profitability, but now I look at your ontology, I see, I'm there with my energy community, but everybody else makes profit with me. So that's my intention or my impression. So who makes profit in your now I call it ecosystem, not ontology. In this ecosystem, who makes the profit, or whom do you help to make profit? Is it your father, Stefan?
I would say if we are able to deploy systems which are based on this common vocabulary, then we will be able to go faster to the market. We reach a higher maturity of software solutions much faster. This might result in lower development costs, lower integration costs. The energy management system itself can be configured to support different optimization goals of customers. And in the end, I would say the end customer could have benefits on his or her bill. The company who is developing the energy management system, like MAPS in our case, could have a benefit because the time to market might be much shorter than without having this common knowledge base and vocabulary. The grid operators are part of our project and providing valuable inputs, but we do not represent the grid or the grid operator in the ontology itself. That's why we put the grid operator on top of this box. But of course, they could also gain some benefits if the energy community, due to the setup, can act grid friendly.
Yeah, just to mention the possibly we just went too fast through the contribution to flexibility, but leveraging having a proper knowledge of the assets and being able to combine these assets. And I had this example with a very simple example, but we can describe using the same approach, the same hybrid energy storage system approach. We can describe all the other assets. We can describe the thermal mass of the building. We can simply add electric vehicles. We can add whatever we want. And at the end, the system, given the ontology, is able to reason upon and make optimal choices. Because if I know, just as a simple example, I can infer using the ontology, the machine, not me, the machine can infer what is actually the storage capacity or the available storage capacity at this point in time. And I can make choices without being aware of the low level details of each asset.
But Vieri and everybody, maybe I don't understand your ontology, but if I were an energy community, I'm happy to have some, I don't know, PVs and maybe a little GHP or CHP or whatever, and then I introduce a storage. We have to talk about who buys the storage. It's not cheap. Okay, so now I have one storage. I'm happy to have one storage. Why should it be interoperable with other storages? I'm happy to have one. And I don't care at the end. I must make sure that all my appliances or whatever I call the generators, the consumers, link to whatever type of grid which is connected to the storage. So why should I care about interoperability of the storage? I'm devil's advocate now.
You shouldn't. You shouldn't. It should be interoperable by design. If you buy, just going back to the music, if you buy a new drum machine, you're not concerned of the drum machine being interoperable with the other instruments you have, because it is by design. So the problem is not of the end user, it's not of the community, it's of our sector.
Okay.
That's my point of view. You shouldn't bother. When you buy, as you mentioned, when you buy a device, you just plug it and you're happy. Okay, you don't have to worry about the plug. Well, more or less. Right.
So what you're telling me is that me as the end customer, consumer, member of an energy community, I shouldn't care about this entire ontology thing and this ecosystem. You guys make sure whatever I buy in the store fits to what I have already. So that's what you say.
No, well, that's the ideal scenario, yes. But probably, as like Nikolai probably wants to add.
So at the end you assume that me or my energy community, we buy a storage, right?
And if the industry is working properly,
it works.
The storage will adopt, let's say, IEEE 2030.5 for the communication layer, will adopt whatever ontology for describing its capabilities, and it will be interoperable with all the EMS that we are using because we are following some standards.
I see your hand, but what you say, it also connects to, I don't know, the grid operator or whomsoever who can use our flexibility. So more or less, they can use my storage to create, I don't call it profit, I call it benefit, okay? So I help with my storage that I buy someone else. And how do I make profit with my storage then? So that is the kernel of my question. But maybe Habib can contribute to that.
No, I want just to add, I think that we should to care about interoperability. From our case, for example, we have gateways and appliances from Arcelix, but they cannot share information with Samsung, with another brand. So more these appliances, these assets are interoperable, more we can provide more flexibility, we can optimize profits, and we can generate more streams. So I think we have to care about this.
But the
for energy companies, we try to buy some assets. We have to see these capabilities.
The profits do not only stem from me operating my storage in my energy community, but my storage giving benefit by giving flexibility, I don't know, to a grid operator, whomsoever, and my storage connects to them. They can talk to each other because they follow the same ontology and maybe the same standards, and then we are fine. And everybody makes a profit. Is that the idea?
Yes, that's the idea. And also in our project, we are combining not only storage systems, or we are combining with flexible loads or smart appliances. So
that will be storage is one of the flexibility sources. Yeah,
exactly. It's another level.
Nikolai, to that one.
Yeah. So what I wanted to say is that I like your question, which is really basic, and talking to my father, to exclude just Mark's one being used as a case. He's like, what's in for me, right? He doesn't really care for all these, fancy words and, energy transition. He's, a working man trying to make his living and trying to have his supper in peace. And, the back to that is the sharing of profits. And that's what, let's say, and us as a software producer, an aggregator, brought to the energy community we are showing here, that they are benefiting by letting us use their batteries. And I think this is the right approach, because if the share, like let's say a share of a profit is not getting back to the users, they will eventually get, tired of being as their, just couple of researchers trying to meddle with their battery.
Yeah, I mean, there's a big discussion. You all know that about energy sharing and who benefits from that, and so. But you, Nicola, you created this energy community toolkit, correct?
True.
Is it energy community or energy sharing? I don't know. But there's a toolkit. Does that toolkit help my father? No, he is in heaven. But your father. What does the toolkit give a real member in a real world energy community in Austria?
Yeah. So first, the tool takes the part of energy which is foreseen to be used for the appliances and the evening, loads, and puts it to, let's say, a saved storage part, and the rest, which is not going to be used, let's say, at least on prediction side, we then put it on market.
Okay.
And then the benefit of putting it on market is then split or returned to the user in this case, because it's a research part.
So if I get your toolkit and I install it wheresoever, it more or less creates my access to the markets automatically. I install it, it starts talking to the marketplaces, it manages the energy in and out. So this is something the toolkit gives me.
Yeah, the toolkit itself is on, just on the cloud. So what you see is, and I come back to that, Vieri maybe, it's a box you will be installed with. The rest our system does, and you get percentage. But the tricky part is, talking to the customers, community members, is, how to present this. This is technical system, I need to do it low level enough that they understand it and they are comfortable working with, and still need to be truthful, let's say, and at the same time not too high level. And that's the hard part for me.
And the box as such, does every member get a box, or does the entire community have your box?
Each member gets its box. That's this LPC, legacy protocol converter. Yeah.
How much is it? Where can I buy it?
We provide it in the project, but this depends where you use it. A member of our project uses Raspberry Pi. This could, I think it's like 100 euros or so.
Some 100 euros, yeah. Okay, so we are talking a bit about the benefits. So the real energy communities, what do they get beyond nice models and nice talks? Stefan?
You showed this ideal world a few minutes ago where everyone will gain some benefits. Of course, this would be a nice future, but we have to be realistic in some cases. You mentioned already buying a storage might be very expensive. We are developing solutions. We are getting public funding for doing this research. So there is already money which has to be used to come to this solution. So this is tax money which we use, and I think it's necessary to work on benefits for customers. And in the Austrian community, in the PARMENIDES project, the background why the DSO joined is that they are already reaching the capacity limits. And they said, we cannot install more PV or EV charging station if we do not either expand the grid or bring in some intelligent solutions. And expanding the grid is very expensive. Bringing in a digital solution which can help for at least a few years to postpone this expansion could already help now. And this could be the fast solution. Of course, the final step will be to expand the grid. Just having intelligent solution might not be enough, but it's a necessary step which we can make now.
But you still talk about the digital part of the story. You are not talking about the costs of the megawatt battery. So
exactly.
Whom do you expect to buy the megawatt battery? That you can control with your nice, easy boxes.
I think this is one topic where still research has to be done. What will be the best business model, and who can do that? Could it be a consulting company? Could it be the community together? I think there are some open questions, and it strongly depends on what can we reach by using this battery. Yeah, I do not have the answer.
But when we have your tools and toolboxes, we can at least make best use of the battery. So the chances increase that we get benefit, right?
Exactly, yeah.
So I see hands. So everybody wants to talk. By the way, our audience can also send questions in the chat, but you are silent. Are you there? Is this somewhere there? So maybe at least one question in the chat, but let's go for the hands. The first one was Vieri, I think.
No, I think Habib was ahead, but I just want to add something to what Mark said, and then I leave it to Habib. Okay, we are forgetting the fact that we're talking about hybrid energy storage. We are focused on batteries, because that's the easy way. Just to remind us that more or less 70% of the energy consumption in residential and commercial building is thermal. So, and we are not thinking we've got this. I'm in a very huge storage, which is called building, and we have huge storage that can store energy for quite a long time, like this advanced technology called hot water tanks. The point is that we have to think that those needs, those profiles, those loads, and the generation, it's solar, so it's always at the same time. We are all generating power at the same moment with more or less the same profile. If we do not, we need to combine them, and then this is 30% against 70%, 80% generation. I think we don't have to be that smart to think how we can combine, how we can couple those different vectors.
Yeah.
Probably if we manage to do that, and this requires a little bit of hardware and a lot of smartness.
As we were talking about our fathers and mothers, would you agree that when you talk to normal people, that the topic heat is a bit closer to them than the topic power? I mean, that is a hypothesis that I created recently. I said, I have been talking to so many people. When I explain them that we are going to do a huge, great, beautiful power system, they said, okay, still power comes from 2 holes in the wall. but they know what a heating is. They can go to their basement and touch the heating. They know what a heating is. So is it easier to get people into a discussion when we talk about HESSes rather than batteries?
From the bill point of view, I would say yes. My electrical costs are marginal. My thermal are not.
Yeah, okay.
Sorry, Habib.
Yeah, sorry for coming in with that question.
No,
we have 2 hands, maybe
exactly.
Going back to the older discussion, who makes the benefit? Yeah, who makes who creates the benefit and who gets the profit? So, is that you want to comment? Was it Habib?
Just I want to say that in our case, we have only one edge computing per energy communities in order to reduce costs. And also our tools allow to provide implicit flexibility and explicit flexibility. So for example, digital twin DSS can notify the chassis owner when they, for example, they reduce consumption or they increase their consumption based on the service that can be provided in order to ensure their long-term engagement and enhance their behavior and to make more profits. Also for explicit, we are controlling, we can say, to optimize the saving, for example, when they store if the price is low, or they can, for example, discharge or sell energy or share energy when the price is higher and so on. So we have to, we support, we can say, chassis owner or chassis node into both an implicit and explicit flexibility provision.
But to whom do you sell that? whom do you sell that tool? I call it a tool. Is it the energy community really, or is it then, I don't know, the local utility or the distribution grid operator? Who is interested in that?
I think this owner also is interested, as we are providing, I think we are testing, we think is a subscription model.
Okay.
So they can subscribe and yes, they can benefit from these tools to increase their benefits and participation in energy communities. But it's low price, I think, subscription. I think €2 to €3 per month.
Later, I would like to come a bit back to the relation of the energy community and the local utility, but maybe the Nikolai's hand first.
Thank you. Yes, I would just refer to Vieri and the heating, and I think that's a good approach. But let's say heat pumps can be tricky, right? But I know a company in Belgium, I forgot the name, sorry for that, but they are working with boilers, and I think boilers were mentioned here by Vieri exactly in presentation. And so the company is pooling, I don't know, thousands and thousands of boilers, and just by changing the default section, which is always a bit too high, they are giving the customers the benefit of not heating too much, and they get the extra energy as a flexibility, and they put it in 1 megawatt box because that's how much it's the lowest limit, and they put it on Belgium flexibility market. So that's a good use case, I would say, but it's really hard to find those, but they can be found. And just one more comment to pooling is that I don't believe energy communities would be, sold the big batteries. That's, how, they're still households. So, putting so much money for a battery is, enormous for them. However, pooling, that's another option.
Hey, we have a voice in the chat. Can you show your face, or didn't you wash it? The member of the board from DTAG. Can you join us and can we discuss a bit with the real customer? He or she doesn't want to show.
I don't know if
I disabled the camera. Yeah,
Right.
I disabled the camera now. And yeah, if you wish to speak, please.
Yeah,
I'm now. Yeah, hi. Do you hear me?
Yeah.
Tobias.
Yeah.
Yes.
Hi, Tobias. Welcome. You are our customer. You are our target group.
Yes,
So,
of course.
do you like what these people offer to you?
Yes, basically yes. But it's always hard to explain it to the people. I think that's the most difficult thing at the whole discussion, because now the people are investing their money in PV and battery. Maybe they are understanding everything about that, but then how to bring them to the energy community is also difficult. And then explaining the people how we will use their battery in a way that is a benefit for everyone in the community. That's very difficult. And also there is the fear that if the battery is more used from the algorithm, it dies sooner. And then they say, oh, I invested like 20,000 euros in my battery, like it's a farmer in our village. And he wants not to participate in this project because he says, no, if there are 5 years less lifetime because the battery will be discharged every day, he will not join. Also, he would be an economical benefit. For him, it's more important to have the lifetime, not the economical benefit, because he wants to use it for emergency power. So for him, it's more important to have the battery.
This is a big benefit for many people. But tell me, I mean, you are in this project and you are collaborating with the local utility, right? I don't know who. Where are you located in Austria?
In Upper Austria, in Dieter.
Upper Austria. So, and your local utility or grid operator is in favor of what you are doing?
We don't have real contact with the grid operator because we just tell him which member will join the energy community, and yeah, that's it. And he makes the energy allocation for us. Yeah, so which member has used how many energy from our community.
Okay.
But
so there's cooperation, but little.
Not really a lot, yeah.
But if we would have such models of providing more flexibility with batteries or combined systems, storage systems, do you think he or she would be interested in what you do?
I think, yeah, because also in our grid area, it was the problem that, as already mentioned, that there cannot be more PV installed because the substation is already full. So if the grid is not being built up in the next time, we cannot install new PVs in our area. So yeah, if the legacy...
They save something, so they have a benefit. They save something. If you behave well, if you use the storage, and if you use this optimal flexibility using the PICO or whatever, they benefit. Yes. And the entire system benefits.
It's also if the legacy is changing, that the DSO can buy flexibility in the market, maybe. Because I think that's not possible at the moment.
Thanks for this, Tobias.
Thank you.
Thank you.
There's a hand from Stefan, but then we have to go into a final round of topic. Stefan.
Yeah, a comment on the systems. If the DSO is then happy, then we are able to do this and that. Of course, then we have to develop solutions and ensure the systems are working correctly. Otherwise, the grid operator will not agree that, okay, there is a digital solution, then everything is fine, and we put PV and EV into the grid. So this is still a challenge to provide solutions which are accepted by the grid operators. We have to create trust in our solutions. And I think, therefore, it's also very, very important to have this collaboration in research projects and show them that the solutions we are developing will help you to have a better life and to allow the customers to install the requested PV panels or EV or heat pumps or whatever is necessary.
And at the end, when it works, and we hope it works, the entire energy supply system will benefit. Everything is going to be better. And who is interested in doing that? Our governments, I would say, or the associations. I told you that in Internet we are discussing a lot about governance. So who drives it? Who says which one standard to use or which ontology to follow? So somehow a bit streamline it or help creating what we call a continuous improvement process that we have invented for that. So we are talking a lot governance, but can we discuss a bit what can governance do? And governance is not only governments, it's not only the lawmakers, it's also energy associations, vendor associations, it's maybe municipalities, so people that try to move things. How can they help you? So how should they?
Tobias just mentioned, we don't have a market for low voltage flexibility services. Right. So why should an end user or an energy community participate to any program? In some scenarios, as Nikolai mentioned, you can operate at a certain level, but the whole point is that I think there are many things that need to be fixed. That's my opinion.
I mean, in other projects, also in Internet, we are talking about flexibility marketplaces or something. We have a flexibility community established and talking about flex offer standards and all that stuff. Is that something where you would say governance should push that, creating markets or marketplaces even for such flexibility trading? Is that what's missing?
Yeah, I would say so, but I think what's missing is their lack of knowledge. I think they are not really keen to change. That's the I think issue I face. Let's say in different projects, a cyber grid. Let's say in Balkan region, when we try to put something up, and the TSO is not really keen on providing any information how to do flexibility, and they are really needed there. You know, the country is in a paying big imbalance cost and so on. So going to these colleagues of ours, let's call them, and you know, explain and help them to really find different approaches then that we can really try to be more flexible, more interoperable. That's the key, right? Because that's an issue. Yeah.
What do you expect, Habib, Stefan? Stefan, if you want, next door is sitting a person from the Austrian BMK ministry, responsible for what we are talking here. Should I invite him to come? What would you tell him if he came in?
Okay, for this question, I'm not very well prepared, but I think, and a bit, maybe one sentence. We recently had the review meeting in the PARMENIDES project, and we got very positive feedback from our project officer, which I'm very proud of. But what he also mentioned is that we should work out a little bit more in the second period recommendation towards policy paper. So he expects that we work on a policy journal paper in the consortium to derive what would be good next step from policymakers.
Okay, that's good. So we should keep collaborating with Internet.
Yeah, of course. Yeah.
Sure. And we do. Habib?
I think in our case, maybe we should provide more and offer more incentives for the creation of energy communities. And in some pilots, we have some, maybe you can reduce barriers. For example, in some countries, in France, in Spain, there are a geospatial limitation of distance. So we cannot can go to more than 2 kilometers between two members. Yeah. So that will limit the numbers of members that can be implicated and involved in the EC. So in 2 kilometers, it's hard to find, for example, 50 members engaged and accept to invest and be implicated in EC. So maybe if we reduce these barriers, give more incentives will be, yes. And support and boost the creation of ECs.
Would your solutions work? I mean, the assumption here, at least my assumption, was always a bit local, because most of these energy community definitions are local. You say it, Habib, maybe too local. If we would have a community spread over, I don't know, a district or a province or what, would your solutions help there as well? Or is it linked to local interconnections? So physically local?
No, for our side, we have solution for local market, but as presenter said before, so we have various use cases, and we can go, for example, for industrial buildings and so on. So we have other possibilities can be personalized and adapted.
So what we agree more or less, we cannot do it alone. We need governance. Maybe we even need guidance. We have 3 minutes to go, 1 minute each. One last sentence on what do you expect, or what do you hope that happens next in governance, in technology, in research, in the Commission? It's not Christmas yet, but maybe you can have a wish, Vieri.
Already mentioned, my wish is, let's try to bring standardization through standardization, not a new standard. I'm not talking of a new standard. Yeah. That's my wish. I will be happy.
And the others? What is important? More technology development, more technology research, more societal research, more interoperability in governance research. What's important?
When we can bring our Christmas wishes, then I would vote for, and since my team is called Power System Digitalization, I'd love to see more digitalization in the field. And this would support all the things we discussed. Otherwise, it will not be possible if we do not have measurements, real-time data, this and that. So this would my wish to for Christmas.
Habib?
From my side, I have many wishes, but let's say
So
that
we do it for
if we
Christmas
can
and
make
Easter, okay?
exactly. So if we can make the energy communities or the chess node in our case profitable and bankable with possibility to create many revenue streams, I think that will be important. And maybe if we can involve big polluting industries and invest and incentivize these ECs.
Thank you. Nicola, you have the last say.
Oh, wow. I was silent till now because I don't really know what to wish for. I would say maybe not a wish, but just to say that I see that the best approach will be the one we will start using. And we have our own approaches, let's say different levels maybe, but someday somebody will come with such a good solution for communities that everybody will say, yeah, let's use that. And that's, I think, the wish to really come to this solution. Now, I cheer for InterSTORE, and of course, the other colleagues will join for their projects. But this, I really wish that we have a good solution for everybody.
Thank you guys for this lively discussion exchange. I would wish that we can go on, but there will be other opportunities. It's 11:45. I promise to hand over in time to Alexandre. But Alexandre cannot speak without a microphone.
Yeah, I know. I just took a very fast call. Thanks for your patience. Yeah, thank you. Thank you to all the speakers. I will just make these closing remarks as a summary and to leave a hope note, let's say, for the future. But I will start by the Parmenides the presentation. I think they kicked off the discussion quite well, framing the importance and giving the pertinence of targeting renewable energy communities as an instrument to manage this very pertinent share of energy consumption from buildings. You stated 40%, and especially for the residential sector, 27%, around these numbers. But also another interesting element, which is only 1/3 of this refers to electricity consumption. And so this really highlights the importance for hybridization and integration of the different resources. So taking into account the thermal loads mostly. Mark presented the PECO development, the Parmenides ontology for energy communities. There is this recognition that in fact a lot of terms are missing from the existing ontologies. And so there is not only this need for ontology to cover renewable energy communities, but also the hybrid energy storage systems. And so excellent work from you guys. He mentioned a curious thing that matches what Nikolai stated several times in his presentation, which is that renewable energy communities are made of people. And so when we target people, it really detaches from that perspective when we look at our optimization algorithms that focus on the minimization of cost or minimization of the environmental impact. And so here we have another dimension with the comfort, because we're talking about people. And then we had Vieri explaining how hybrid energy storage systems can be explored in renewable energy communities. Again, considering only that the electricity represents this 1/3 of the energy consumption, and so that the other energy carriers should be considered as well. And these can be aggregated and provided as flexibility. There was an example provided, very interesting, with this electric boiler and the BESS, and how to represent the messages and the values of the physical properties of these assets. So very nice. And in terms of interoperability, I mean, they focused on the business layer, the function layer, and the information layer. So again, very nice presentation, guys. On the FLEXCHESS project, Habib presented the architecture, integrating the the Flex platform and the physical layer chess nodes. So very interesting as well. And the FLEXCHESS community-driven profitability. This was quite a novelty with a set of smart contract approaches. Very interesting, enabling different incentives, let's say, that can reach the final consumer. So glad to hear from this point of view. And in InterSTORE project, Nikolai presented the full chain integration of what we are doing in InterSTORE with the IEEE 2030.5 main developments, which are the legacy protocol converter, which is applied to legacy equipment, but that being read by a native client server library, which is the other development, with the IEEE 2030.5 dictionary. Let's say this hosts the dictionary and able to understand the mapping and the messages received. And also he touched upon the point that we have in the project that we are including the data space environment to share data. And all these developments are so applied to renewable energy communities. In the fruitful discussion promoted by Ludwig, very nice, it was recognized that renewable energy communities are very important. So because it involves people, it enables literacy increase and the awareness, and mostly active participation, because we're always told and we follow the energy strategy, European energy strategy, to put citizens at the core. And so this is quite a pertinent way to do it. People get to decide on what and how they want to contribute. If they want, again, to maximize autoconsumption, minimize cost, maximize independence from the grid, maximize the comfort that we were just saying. And it was defended by the speakers that there will not be the need for consumers to be involved or to have contact with the ontologies. And I do agree with this. I mean, this is a back-end structure that has to be created, and the goal in the end is for the assets to be integrated. You cannot be integrated if your asset does not speak and does not understand the common language that is enabled by these common dictionaries that are the ontologies. Just to add here, it was implicitly said that the consumers will be aware of the ontology or the interoperability enabled devices, not because of the theoretical part of what it means, but because of what they can do. What are the extra functionalities that they bring, and how do they add value? They will add value in some way. And Nikolai provided this narrative, and I think it captures quite well what we are trying to do, which is using the IEEE 2030.5. The communication will be a many-to-many communication. So right now we'll have assets not only talking to our energy community managing platform, but we will have assets being capable to speak with not only the managing platform, but with the aggregator, with the DSO, with another energy management system, beyond the limitations of many communication protocols, such as comes to my mind Modbus, that has this relationship between server, slave, and master and slave relationship. And so the IEEE 2030.5 goes beyond and breaks these strict ties, for example. So the role of interoperability is a backend requirement to integrate and link all the distributed resources, and this is what we are trying to do, and a common vision and mission of all the projects. And there is also the topic of integration of resources with very different physical capacities, and this diversity should not be forgotten in hybridization. So we talked about the boilers and thermal loads. Yeah, and so I think we will have much to reflect after this webinar, and to access and use all the open source tools that were here shared. So I invite all the attendees to do so. And our time has come to an end. And I would like to thank everyone for their participation. to the speakers, to the moderator. It was a pleasure. I hope to see you soon from my side. It was a privilege to moderate the session. And so we are well past our time. And with this, I close today's webinar. Thank you so much, everyone. Thank you.
Thank you very much.
Thank you. Goodbye all.
Have a nice day. Goodbye.
Have a nice
Bye-bye.
day.
Bye-bye, guys.